welcome to Pulse by AlphaWire, the podcast where science and education meet cutting-edge technology and artificial intelligence. My name is Aldo, and each week I sit down with innovators, thinkers and doers who are working to change our world for the better. Together we explore their journeys, uncover the lessons they've learned, and take the entrepreneurial pulse that drives them on their path to success. This week I speak to Albert Anis, founder of Valleydow, about the infinite potential of computational biology on our future. We dive into the many positive effects that synthetic biology can have on our lives, with a specific emphasis on climate change, where Valleydow's specific focus is. Albert is from Sweden, living in Brussels, and has an advanced background in biotechnology. Hope you'll enjoy my conversation with him. Yes, and we're back with a new episode, this time with Albert Anis, founder of Valleydow, another friend in decentralized science. Albert, a very good afternoon to you. How are you?
Doing well. Got a lot to chew on these days. There's a lot of things happening in DeSci, and we're trying to stay at the top of things. But always pleased to chat with you, Aldo. Yeah, as you said, we've known each other for some time now, and always enjoy a conversation with you. Centuries, eons.
Yeah. We go back to the year of our Lord 2023, I believe it was, in Taiwan.
Yes.
At a conference
Year zero
there.
of DeSci.
Yeah, exactly. Decades in DeSci. And then we were both at this wonderful conference, and you were so kind to be a little bit of a guide through this world that is DeSci, but it was at the Taiwan Blockchain Week, right? Now I remember. And it was a Sora Summit. That was the name, Sora Summit. And we were very hopeful that big things would be said about DeSci, because Brian Armstrong was calling in, saying some things. He said some things which were nice, but they weren't as revealing or shocking as we hoped it would have been. How do you look back upon those days, the Taiwan days? Did you enjoy that conference?
I did, and it was a little bit of the themes were very random. Like, it was DeSci and Bitcoin ordinals. Two things that you wouldn't expect people to like combine. But I gotta give it to the guys at Sora Ventures, the organizers of this. They both made pretty good decisions on what to focus on, because both of these sectors really took off. DeSci, I would say, a little bit more than ordinals, but that's probably going to come back at some point. I mean, Taiwan is great. I think there should be more crypto activity there, in my view, but there's not enough. It's like perfectly set up for that. And so, yeah, looking back at it, I mean, a lot has changed. I would say DeSci has, of course, like matured even more, established its role like in the larger like crypto ecosystem, particularly for just being able to demonstrate some positive results from, for example, the different funded research projects, but also the innovation in funding models for science. And so I think we still have like a lot more to come and to develop and improve. But things in science takes time. So I mean, for us, like we fund research, and then we try to bring it towards different commercialization points to increase the value of a particular project, and that takes time. And we've been a couple of years in the game now, and some of those projects are really starting to mature, and the whole space just looks much less like a scam, which everybody used to call it, and still perhaps call it, but everything in crypto is a scam. So from the observer's
that's true.
point
We've
of
been
view.
fighting that off from the very start, right? And even if you don't want to be a scam, there's something scammy happening around you, and then people kind of just draw one line under it or through it or over it. So that's also like, even if you're on your very best behavior, which many of us are in DeSci, there might be something happening right next to you that you're kind of like, yeah, well, that's not me. And you kind of need to distance yourself from it in a clever way. And then, but at the same time, it's also part of your ecosystem, of your business. So that's always a difficult thing to navigate through. But I want to talk about Valleydow, and I want to talk about what you guys are doing, because you guys spend a lot of time on educating your community I see wonderful videos, wonderful spaces and podcasts coming by, infographics. You spend loads of time educating your audience, and I've seen a lot about climate change. So can you talk me through about what ValleyDAO is and specifically what kind of where you think you could make a change for the better when it comes to our climate?
Absolutely. So currently, like the DeSci ecosystem right now, the main type of science that is being focused on is biotechnology. For example, with Genomics, you focus on human genomics. Other DeSci projects, they focus on different verticals of like human health. And it's usually about, funding a project that intends to, let's say, test or discover a new type of pharmaceutical or biologically active molecule to cause a certain change in the human body, whether that is like living longer, cure cancer, or a specific type of cancer. Now, biotechnology's application, where it can be applied, is much, much like bigger than that. It's much, much bigger than human health. There is this whole industry called climate biotechnology or industrial biotechnology, where the focus is on more planetary health. So, how can we manufacture goods, commodities, foods, fuels, things that produce energy, materials like textiles, for example, in a way that releases, for example, less emissions, or in a way that doesn't use toxic chemicals that, for example, goes into the soil, ultimately into our drinking water. For example, microplastics is a big one, but microplastic is really just a blip in the larger problem space that, things that are actively negatively affecting the climate. And so, there's a lot of people out there who don't believe that, carbon emissions negatively affect, the global temperature, for example. For those who don't believe that, maybe this conversation is not really for them. But so what we want to do is like we want to enable projects that uses biotechnology to improve planetary health. So to give you like an example of a project that we have enabled through Valleydow, is a project that it's based in Australia at the National Research Institute called CSIRO, CSIRO. Basically, it's like the national lab, like similar to national labs in the US. And what we're doing there is like we partner up with these brilliant researchers that have worked on taking electronic waste, spreading it down into like fine powder. So electronic waste like motherboards, computer parts that are just piling up in landfill. So taking that, shredding it down, and combine it with special kinds of microbes. So these microbes, like bacteria, basically, that naturally produces a cocktail of different chemicals to break down these metals and basically refine them and recycle them into pure metals. So
Yeah.
imagine then, you can create like these circularities with biotechnology instead of, for example, using a traditional chemical process that takes a lot of energy, takes a lot of heat to do that same thing. With biology, you can do it at room temperature and much more mild conditions. So just to give you one example, there are tens of different examples, but just to give you an idea of the type of research and the problem, areas that we're focusing on Valleydow. Essentially, how we enable and support these projects through DeSci and through blockchain is by crowdfunding. So giving people the ability to put capital towards projects that we go out and we find them and we bring them, we review them and make sure that they are like really the best possible research that we can fund to further the field as a whole. And then people, can invest in them and own essentially a share of the intellectual property that is generated. So for example, the e-waste project that I just mentioned, the technology itself that is being developed there, people will be able to own and get exposure to the potential success of that technology. Does that make sense?
Yeah, it makes sense. I have a couple of questions. So, how would you peg ValleyDAO? So, are you an investor then? Are you an incubator? Are you a facilitator, a platform, a crowdfunder? What would be the first one? If you can spend one sentence on ValleyDAO,
Mhm.
what would you say that ValleyDAO is?
I would say we, at the core of it, like we are a community of highly technical people in biotech that are coming together to fund and support research projects in this field. So there is like investment activity, there is commercialization activity, and there is also the educational activity to make more people aware about this field as a whole.
Yeah. And so, because I think biotechnology, synthetic biology is very fascinating, and it's growing very quickly, I can imagine, right? So what was last year is already kind of, it's already a lot bigger than that. I think we need loads of data. We need it quick. We need to kind of make sure we make solid decisions based on loads of information. So I can imagine that biotechnology has it accelerated with AI, coming more to the forefront, or this enormous explosion of AI everywhere, or what are your findings on the basis of that?
My findings based on that is that I would say synthetic biology for a long time, like before AI, had the issue of like in synthetic biology, like it takes a lot of resources to produce any sort of data. So to do any sort of experiment, it takes a lot of resources. It takes human labor, it takes trial and error, it takes time. What is really promising with AI is the ability of AI to control like a robotic instrument that can, for example, do pipetting. And so you can streamline, like biology requires a lot of experiments, a lot of trial and error. Sometimes it can almost be like brute forcing to get to something interesting and productive. So, I talk with researchers and founders and builders in synthetic biology right now who are focusing primarily on the automation infrastructure. So a lot of focus is being put on that currently. And so that's one thing I am excited about. Is that effect being seen right now? Like that, are we seeing like some sort of output from that yet? On that, I would say no. I think it will take like another year or two, maybe 3-4 years, honestly, before we see any significant improvements, any leaps, right? Usually you don't see them until like they happen. And so I think a lot of technical initiatives like brewing in the background right now, in terms of like accelerating this field as a whole. And so I don't think, synthetic biology is going to have its like AI moment, where it's like, hockey sticks and we get like widespread adoption. I think it's going to take a little bit more just to be on the realistic side. Yeah. So actually, with, after COVID, after the funding landscape, started drying off a little bit, a lot of synthetic biology companies actually went bankrupt, having raised too much money, wasn't able to deliver on results and so on. And we started with Valleydow around 2022. So essentially, when synthetic biology was almost had its worst moments, and what we told ourselves is like, okay, let's sit down and let's actually try to fundamentally understand the challenges in synthetic biology, the technical challenges. And there is no better way of understanding these fundamental issues in a big research area than in a community setting. So, with technologies like the way Discord has changed online culture is really good. Is really good. I would say like the people being attracted to these communities, joining them, getting involved, getting their hands dirty, and sharing, insights from, like, we have people in the community who's worked at a big pilot facility where they are manufacturing, hundreds of thousands of liters of a particular material, and they're actively involved like in our server, in our community, supporting projects, helping us understand risks and technical challenges that a traditional company would have to pay $500 for
Yeah.
per hour to get that type of consultation. And so like that's the thing with DAOs, is like they align incentives, they bring people together, and then that effort is focused on a particular issue. It's one of our priorities to like keep asking ourselves the question, like, why didn't things of the past work, and how can we harness the sort of like the collective intelligence of the community to make better decisions.
Yeah. And where are we now with synthetic biology? You say 2022 was like, a bit of a low point. And how is it going now? Are we waking up to the notion that it is needed and that it should grow?
No, yeah, there is definitely increased sense of optimism, and there are like companies coming out every day that have actually managed to crack, like different scaling issues, like so basically like scaling up their manufacturing. So yeah, I remain like quite optimistic.
Yeah. So I'm curious about the companies that you work with. How do they find you, or how do you find them? Because I can imagine these are people who are very into their field, very entrenched, maybe not so familiar with the world of DeSci and Web3 and crypto and have you all that. And then how does that come together? Do you scout them or do they approach you? How can a company get in touch and what's the journey like?
We don't work with that. We don't actually fund companies. We fund
Okay.
research projects at universities. So we
Research person.
start
Sorry.
at an
Yeah.
even earlier stage.
Okay.
And
Yeah.
we essentially try to find, so we go out there, to answer your question, we go out there and we try to find them. But we also have, the ability for people to apply and get in touch with us and say, hey, like I'm working on this project. I'm looking for like this type of funding or this type of support. And that's like how we initiate some of the conversations. All the times, and most of the times, we look at the whole research landscape. We use a lot of like data analytics to like scrape and find all of the researchers in a particular subfield of synthetic biology. We try to really, understand the problem space and look at who is like solving the problem in what we consider is like the smartest way. Usually, these people are good with numbers, so they can like show you a calculation of like this is how much it's going to cost, and my solution can like develop this type of product at this price point. Because one challenge in synthetic biology is margins. So you really have to think about the economics of the whole process.
Mm.
um, and yeah, and then we reach out to them, we initiate conversations, and the benefit we have there is like since we know their research quite well, they're very keen to like talk with us and open up and initiate something.
When you say the problem in synthetic biology is margins, what do you mean to say by that? Is it very expensive and therefore it's hard to charge a premium over it? Could you
You
explain
can
that?
think about it, yeah, you can think about it like in computers in the 70s and 80s. Like if you remember or how much your first computer cost, at least like $1,500 in the early 2000s, maybe, yeah, like a good computer. And then the computer industry, uh, given that there was so much demand and a lot of engineering effort was put into it, we managed to decrease like the cost of producing like a microprocessor to produce chipsets, to produce graphics cards, and so on. Because we create like supply chains, and we outsourced it to China when we found like cheaper labor. We got like automation. We got literally machines that print circuit boards, for example. And so that, today, like you can get like an extremely powerful computer for like $700-800, even cheaper perhaps. All electronics are just much 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 more cheaper. And currently, like synthetic biology is at that point where like scaling is expensive, but there are people who are working on scaling infrastructure, who are working on like the manufacturing part of producing different biologics, and thus like the cost curve is decreasing year by year.
Yeah. Okay. Yeah. So you say the cost will come down and therefore it will become more popular. Currently, it's still relatively expensive. So people might not want to go ahead. Yeah.
Yes,
Yeah.
as you
Yeah.
said.
Yeah. So I want to talk a little bit more about climate change because in your remit to find projects, do you now focus on kind of the impact that they have? So is that then all climate change, or are you more saying, well, if it's an interesting research project that embraces synthetic biology or looks into that in more detail, we'd be keen as well. Do you like in your choice of projects that you support? Is there a clear thematic focus, or is it more like a utility focus?
I would say like every project that we fund needs to generate some sort of product or solution that positively impacts the health of the planet.
Yeah. Okay. So that's good. That's your common denominator.
Yeah, and that's also our differentiator in
Yeah.
DeSci.
Yeah.
We are currently to my knowledge, and I have a good overview of the DeSci ecosystem, the only DeSci project with a sole focus on climate impact right now.
Yeah.
Some people hate us for it, and some people, love us for it. Because I mean, climate skepticism and climate denial has increased quite a lot just in the last 3-4 years. I understand why, because there was a lot of miscommunication about it, a lot of like fear mongering about it. And so the approach that we want to take and that we're actively pursuing is we want to focus on the utility. Like, how can this not only positively impact the climate, but how can it produce a product that is just superior to existing alternatives, right? It's more on like the value add rather than, okay, this is good for the planet, because that's what people fundamentally understand, right? Because the like climate change is like a very abstract term. You can't really conceptualize it, but you can conceptualize a product that doesn't have any microplastics, because it doesn't, that, okay, if I use this product, I can ensure that I will not get microplastics in my body, in my endocrine system. And I think like if we weren't focusing on like if we because there are, for example, very technical projects that we could pursue in synthetic biology, focusing on like how to like engineer the metabolism of a cell in a really like CRISPR, right? The thing with that is like if we focused on those kinds of projects, our community and our audience wouldn't be able to put it into their everyday context. And so that's why like focusing on projects with a clear use case and that token holders, your average Joe, can relate to, is becoming like an increased priority for us.
Yeah.
So one example is Hempy. So if you go to www.hempy.science, you'll find one of our funded projects that we focus on, where we are taking hemp fibers, which uses way less resources than cotton, doesn't need any sort of pesticides to grow, and you can grow it everywhere in the world. Like where I'm from in Sweden, like you can grow it there, and it's super cold, but it grows literally there as well. And the thing with hemp is like it can potentially outcompete cotton as a material for the textile industry. But the challenge with hemp is that it's quite stiff and it's a bit rough. It wrinkles quite easily. So textile like mass textile manufacturers, they don't. That's not their choice when they choose like which material to use. So what we're doing with Hempy is we are taking enzymes, which are small molecules that can cleave different parts of the hemp fiber and remove the things that makes the hemp fiber stiff. And so by softening the hemp fiber, we essentially turn it more into cotton. And thus, we can present to the world an alternative to cotton that is much better, uses way less resources, way less water, doesn't use any harmful pesticides, and have an impact on an industry that is responsible for almost 45% of all global emissions.
Yeah, that's an amazing story, and people can check it out at hempy.science.
Hempy.science.
Yeah, nice. And so where did you come in this process? Like, did you set it up? Did you identify the research project as Valleydow, and then you grew it as a community with your support and funding and all those things?
Yeah, I'm always in the trenches. I post on LinkedIn. A lot of people reach out to me through that way, and that's how I make the majority of my connections. And so we got in touch with this really talented research organization in Austria, in Vienna. They're called the Austrian Center of Industrial Biotech. So ACIB is the shorthand for it. And what they do is they do R&D for a range of different big companies like BASF, Novo Nordisk, and so on. And so basically people go to them and like ask them for help with a particular research project, and then they do the science in partnership with you. And so we got introduced to a researcher there that focuses on polymers for textile materials. And he was quite bullish on hemp, and he convinced us about it. So we started learning much more about it. And then it was like, okay, why isn't this much more mainstream, like with all of these different benefits? And then we learned that hemp's history comes from like a long history of suppression because it was associated with marijuana. In the US, there was like a crackdown on like basically the war on drugs and so on. And so the hemp industry never took off. And now like more and more people are like waking up to it and like, hey, this is actually a crop that uses less water, is more productive, it produces way more biomass per hectare, and it literally purifies the soil that it grows on. So it picks up like toxins from the soil and it gets rid of them. And so what we did is like we established a partnership with this researcher, and then we created a crowdfunding campaign where people could contribute funds and in return receive these so-called IP tokens, which represents a fractional ownership in the whole project. So if the project is successful, you're part of that journey as well by holding these tokens.
Yeah. And so if the project is successful, then the value increases. So what you possess in terms of that IP token also is worth more, correct?
In theory, yeah. Like if the project is successful and the market sees that, I mean, ultimately it's supply and demand. It's ultimately like if people become more bullish on the project and it attracts more, token holders, for example. So our main priority is to continuously increase the value of all of our funded projects by bringing them to different commercialization inflection points. So that could be a technical inflection point by improving the enzymes so that they make the hemp even more softer. Another technological milestone would be to actually take these hemp fibers that we modify in the lab, that we treat with these enzymes, and spin them into yarn, and then put that into a product. And in our view, like our ultimate success story is to get a product like this into the hands of an IP token holder. And so we've made some pretty good progress on that with Hempy, and hopefully in November this year, we're having like the first launch of a Hempy hoodie enabled by this technology.
Nice. I get your point though about why it had a bad rep, because just in the very beginning of our conversation we were talking about crypto and whatever. There's another use case for Hempy, which is one that people, want to be less associated with. But if you let that go completely and just go for the one that you described, then there's so, much positive change that can be made. That's really remarkable, right? That's amazing. Yeah. Nice. Yeah. I want to dive into the area whereby essentially my company, Genomes.io, meets Valleydow, and I think we've had a short conversation about that earlier, which is synthetic genomics. What, if anything, can you say about synthetic genomics? Is it something that you can be used for climate change? Let's start there.
I'm keen to answer that question. If you could define, because I think synthetic genomics, like how I interpret synthetic genomics, is if you, let's say, take a yeast strain that is really good at producing cocoa fats that can then be used in chocolate, so that you don't have to ship and produce chocolate halfway across the world to ship it to, let's say, Europe or the US. What if you could produce everything locally? So we're working in a project that we're working on it with a yeast strain that can do just that locally, as long as you have access to like steel, water, and sugar. And so that strain, that yeast, it has a genome, right? And what we're doing is like we're modifying a set of genes in that yeast to make it behave in a way that produces more of what we want it to do. In that sense, like you could call that synthetic genomics, because we are synthetically introducing new genes and we're creating a derivative of that genome. And so that is what like synthetic genomics is to me. But I mean, to you, there's probably like
it's
a different definite.
No,
exactly.
You're right. No, so there's synthetic genomics in the way you talk about it, which more refers to genetic engineering, which is essentially, there's just a Wellcome Trust approved this program in the United Kingdom whereby they build a synthetic genome, right? So it's completely artificial. The entire creation process is artificial. When I say synthetic genomics, I actually mean more simulated genomics or genetic simulators.
Mm.
So what that speaks to is genetic data sets that in its buildup are completely like your genome or mine, with the exception that the entire genome isn't of someone who's alive. So it
Mm.
is simulated as
Yeah.
if it could be of a human being, with the exception that it isn't. And so there are loads of those simulators out there, and we're going to work with them through our subnet on BitTensor. So that is growing now. That's kind of an area that we're going to dive into, which is all
Mm.
going to lead to hopefully giving more robust intelligence to the pharmaceutical industry and kind of their R&D departments and their ability to work with genomic data that is safely sourced, that is produced at scale, so that they could use in the hundreds of thousands, if not millions of data sets for their analysis. And that also speaks to a very precise condition or disease or ailment or whatever it is they're looking for in their drug development and drug discovery trajectory. So that
Mm.
is, I appreciate it's
All
slightly
right.
different. Yeah. But
Yeah,
that is
yeah,
where
yeah.
I,
But
yeah,
what I can say on that is, I mean, is it similar to like does the I've heard of this concept of like a large genome model, like a large instead of like a large language model, you have a large genome model, which basically, if you give it some sort of skeleton of a genome, it can complete that skeleton and get sort of like guess what goes into the gaps of a particular genome. Is it some like, do you guys do something related to this currently? Like, is it in this direction?
it is a little, but it's more, I think we're more practical in the sense that we curate from the simulators. So there are simulators active. So this is a field that is growing. More and more research institutions produce simulators that effectively function on live input. So for instance, in the public domain, you have something called the human reference genome. The human reference genome is the input for such a simulator. So on the basis of that input, they can recreate loads of other genomes that can then be used for further research, right?
Okay, got it.
So that might not be the skeleton that you're looking for, but the kind of the input is real life
So it
input
creates it
of
from
a
scratch, like it creates the genome
correct.
from
Yeah,
scratch.
yeah,
Okay,
yeah.
okay.
And so
That's very
yeah,
exciting. That's I think
yeah,
I mean a genome, the fundamentals of a genome in a human and in a plant and a bacterium or in a fish, it's built with like using the same language. And so these genome simulators that you're creating, I mean, you could technically like swap the training data from human data to, let's say, yeast data or like some plant data, for example, and you could achieve very similar outcomes and design, let's say, new strains of oat, for example, or barley or wheat, right? That perhaps perform that, are way more productive or that are naturally like resistant to different pesticides. But then you get into this whole like GMO debate, which is a sensitive area for a lot of people. I mean, but ultimately that is the future we're heading towards. The scare and the fear mongering, for that is quite big. But the impact it could have, could save
is
and
massive.
put,
Yeah,
food on the table
yeah.
for the whole planet.
It's a big discussion. I completely appreciate that. But I mean, if you look, for instance, and I know that's not kind of engineering or modification. Well, maybe it is. Like gene editing. The fact that we're able to cure people of extremely destructive diseases because of gene editing. That's the world we live in today. Like that's progress that every step of the way I embrace. Right? You could argue like, okay, let's create the first human being out of synthetic DNA. Okay, that's maybe one step too far for me. But I think the fact that we can help substantially contribute to the health of many, I don't think that's something I, for one, would be against. But hey, I'm
Mm,
not everyone, and everyone is of
yeah,
course entitled to their opinion. But yeah,
yeah.
yeah,
But that's just technology history 101.
yeah,
It
yeah,
always, begins like this, and then the value is just too great to just ignore or,
yeah,
say no to.
yeah,
And I think, as a Christian myself, as a Catholic, I know like the stance of like genetic engineering and genomics and in vivo fertilization like of the Catholic Church. I'm fully aware of like what they think about it, but even they have started to see like how they can position themselves in this inevitable future,
Yeah.
right?
Yeah.
And so it's like the moral authority, which is like the Catholic Church, or usually so usually it begins at some like in some religious context, right? Will ultimately create frameworks that we as humans can feel good about, and with time we're going to see like widespread like acceptance of these things, and the Catholic
Yeah.
Church is doing the same with
Yeah.
AI as well, because it's sort of like AI has like it's gotten so good right now to the point where you can almost ask it like yourself, like, does it have a soul? Like, is it a sentient thing, right? So yeah, it's a crazy time we live in,
Yeah.
but a lot of things are converging right now.
Crazy but exciting, I'd say, right? But
Yes.
yeah, yeah, it's um
Crazy can also be good. Yeah.
yeah. So I want to talk a little bit about how you got into this. So what drove you to say, "Hey, I'm going to start up this community whereby I'm going to help other research projects in synthetic biology to flourish." So how do you start such a journey?
I've always been a believer that uh, the key to success is always through collaboration. Um, and if you can create something that brings people together, that aligns them on a common target, and also at the same time incentivizes them and give them something back, very interesting things can start happening. So having that mindset and finding crypto back in 2017, it wasn't until like 2020 where I started like really looking into using crypto as a platform for global collaboration, where contributors of that network can share like the success of a particular outcome. And so decentralized autonomous organization was sort of like the idea of it. I know it's not like a perfect framework, and I know that all DAOs are not fully decentralized, but just that philosophy, led to the creation of Valleydow. And because like my background is in climate biotech, I studied molecular biotechnology. I participated in a lot of like student competitions and created like student teams that competed with each other on who could create like the best experiment and the best project, led to the creation of Valleydow and having that particular theme. Honestly, like Valleydow was created, I found like the DeSci movement was like bubbling. I ended up in a couple of servers. I wrote a message on one server like, who's interested in synthetic biology, climate biotech? Let's meet at this time. Here's a Zoom link. And then around like 20 people joined. Around three of those people are still actively involved to this day. And of course, like a lot of people have joined since then. I was just following my interests, honestly.
Yeah.
And I think a lot of
Yeah.
those people that joined that first call were also just following their interest. And it wasn't that, to be frank, it wasn't that I had this urge of like saving the climate that I needed to do this, right? Ultimately, what I just want to do is I just want to bring people together to develop interesting technologies that can improve the planet.
Nice. I like that. You were just following your interest. So your interest was with crypto, unrelated to necessarily your academic field, and then you said like, "Hey, what if I combine one thing with the other to a certain level?" Right?
Yeah, yeah, yeah.
Yeah.
And I also
Yeah.
wanted to like, crypto was all, and it still is to some extent, like all speculation, but it was pretty wild in 2020, 2021. And then just seeing like people doing science, adjacent to crypto and trying to really improve the the academic system, the scientific ecosystem. That to me, gave me a sense of like, okay, something serious is happening here and it's worth looking into.
Yeah. Nice. Albert, what are you most proud of?
Um, Having met you and becoming such good
Ha
friends.
ha ha ha. Yes.
There's many things to be proud of. I am honestly, I'm very proud of my team and my community and the people who, show up every day, even at like the low points of the market when there's like nobody around. People who just, keep on showing up to the work group meetings, people who are active in governance, commenting and like stating their opinion about a particular research project that is about to be funded, both stating optimism but also criticism, partaking in a constructive conversation. That is something that I'm very proud of, that we have been able to create such a dynamic online and putting it to a productive use.
Putting it to work. Yeah, that's good.
Yeah.
That's true. That's good. And that is, you're right. You can be proud of that because it's one thing just to moan or to kind of, say that the world should be better. And it's another thing to really put your shoulders under it and to get to work and to really try to make that difference. And I'm sure, that is what you are doing. So yeah, no, that's great. Before I get to my very last question, I just wanted to know, what should we look out for when it comes to Valleydow? So I see you speaking a lot to your community. What should people know about Valleydow in the near future? Is there anything they should look out for?
We are creating the most planet-friendly hoodie as we're speaking. And a lot of this activity will go live in November, according to the timeline. And so definitely keep your eyes peeled on Hempy.science. We also recently initiated a partnership with a company creating biomaterials that are just mesmerizing to look at. They both have like a use case, like in the construction and installation, super sexy, I know. But they also have a very aesthetic touch to them. And we want to introduce these materials into everyday products within the homes of people. And so with that, we are looking to create something that, blends art and furniture into one. It's made out of a living material. So it's like a material that once it's produced, it's inert, but you can bring it back to life and it will start like growing again if you provide it with the right ingredients. And so providing a product that changes people's perspective on what biotechnology can do. Because one thing that I've started realizing more and more is like the word biotech for the average person is like human medicine, pharma, right? But it is so much more.
So
And I
much
think
more.
if we
Yeah.
can introduce a product that was made out of biotechnology into the hands of someone that they can look at and interact with on an everyday, it can fundamentally change how people think about biotech and what they associate biotech with. So that for us is part of like the impact that we want to enable.
Yeah. Nice. Well, those are two wonderful things to look out for. And then my very last question, Albert, and I ask every guest that I have, it's about reading essentially. And by reading, I mean that in the broadest sense of the word, like, absorbing knowledge. But on your path, has there been any kind of reading or any book or any platform, magazine, whatever it is, that kind of inspired you to kind of do what you're doing today?
Not that directly inspired me, but I'm just going to show the book. I'm reading this book here, The Beginning of Infinity by David Deutsch.
David Deutsch. Yeah.
Uh, and this book, like he is basically trying to explain this phenomenon of infinities like occurring in different parts of like the universe. And I mean, I still don't fully grasp what this freaking book is about, honestly, because every chapter is like he's talking about quantum physics, he's talking about like multidimensionality, the idea of infinities. And to be honest, I don't have a full grasp of the point that he's trying to make. But why I find it so valuable to read is that it enables me to think in ways that I usually don't. And so
Okay.
I constantly, when I read this, it unlocks parts of my brain that, yeah, just motivates me to just learn more, to just understand the universe. And so that's what I'm currently reading right now. But when it comes to books that have inspired me to do X, Y, Z, that's a tricky one.
This is good already, right? Don't worry. I mean, some people are very, outspoken about it, and others are not, right? So it's kind of like I had the guys of Research Hub that I spoke to the other day, who have PhDs, and then Jeffrey Corey, who's president of the Research Hub Foundation, said like, I'm not much of a reader, really. I am too ADHD to read. I can't get myself to finish a book. I just read half and then I already want to go do it. So it's to each their own. And he was more inspired by people, like, people who said
Yes.
something and they've written a book around it. And yes, that sounds interesting, but doesn't mean you read the whole book from A to Z, right? So there's
Yes.
loads there. So I'd say it's kind of a concept, something that absorbs you, something that makes you passionate about what you do.
Absolutely, absolutely. And I totally agree with Jeffrey. Like, I am more of like a peer-to-peer interaction type of person. Reading is just a way to just make things slow down, honestly.
Yeah. Yeah. Yeah.
And just, practicing patience is something that, I've wanted to just become much, much better at. But so yeah, if you see Jeffrey, send my regards. He was actually also in Taipei. I'm not sure if you got to meet him in person
No,
there
I
too.
met him. Yeah, we met him. We met him way back when. And actually, I owed you an interview. So now we've made up for that. I hope, Albert, with this wonderful interview. Thank you so very much for your time. Where can people go if they want to find out more about Valleydow?
Valleydow.bio. Valleydow.bio.
Valleydow.bio. Sorry, yeah,
Yeah. On
Valleydow.bio.
on X, it's Valley_DAO.
Valley_. I will be sure to include it in our show notes. I'm sure we're going to hear a lot more about Valleydow in the near future, as well as we're going to hear a lot more from you, Albert Anis. Thank you so much for your time.
Yes, thank you for having me on. It was a pleasure.
You've listened to Pulse by AlphaWire, produced by Natalie Piles and Amela Faisal, with great music, The Optimist, written by Holly Hamill, performed and produced by Aldo. Episodes hosted weekly by me, Aldo the Pug.